goes the recording. Alrighty, so let's see, we're going to go back to Desmos, which means I'm going to share my screen. Okay, and so you guys can see the screen here, right?
Yes.
Yeah.
Okay, so we're going to enter the equation, a polar equation, rather, the equation of an ellipse in polar form. And the way we do that is we start writing R equals fraction. So actually, let me go back a step. I'm going to write 7.5 and then the fraction bar, okay, which is the key with the question mark on it. And then in the denominator, 1 minus 0.5 COS. And then I'm going to write the word theta, THETA. And did you see how Desmos automatically gives me that Greek letter there? Santi, did you see that?
Yes, I did.
Okay, and Aaron, you saw too, right?
Yeah.
Okay, all right. Now, and then we get this magical ellipse that pops up. And the ellipse has a focus at the point 0, 0. I'm wiggling my cursor over it with my mouse. And then it also has a focus at 10, 0 over here. Okay, and so I think the first question on the quiz is, which way does most of this ellipse go? Does it go to the right, to the left, up, or down? So which one would you say? Santiago, what do you think? Aaron?
It goes more to the right.
Yes, I would say so. Santiago, do you see the same thing?
Yeah.
Okay. All right, so it goes more to the right. Now, I gave you this assignment because I want you to play around with this. Let's go back into our equation, and the minus sign in the denominator, let's turn that to a plus sign. Okay, you see I turned it into a plus sign?
Yeah.
And what did that do to the ellipse?
Made it move to the left.
It made it move to the left. Santiago, you see the same thing?
Yes, I do.
Okay. Now, that's one possibility. Okay, now the next step is I'm going to keep that plus sign there, but I'm going to change the cosine, the COS, I'm going to change that into a sine. So I'm going to go SIN. Ooh, and what did that do? Which way did the ellipse flip?
It went down.
It went down. Right, Santiago?
Yes.
Okay. All right, and now I'm going to change that plus sign into a minus sign. And what did that do to the ellipse?
It went up.
It went up. Okay, good. All right. Okay, so so far so good, right?
Yeah.
So you see that changing the minus or plus sign flips it back and forth horizontally, right? Either from the right to the left or left to right. And changing the sine and cosine flips it vertically, right? So let's go back to the original form, which is, ooh, that's an interesting looking pattern. Do you see that?
Mm-hmm.
What do you think of that? It's a couple of spirals, right? But
Yeah.
we'll look at that later. Okay, so let's go back to the cosine, and there's our original ellipse. Okay, now we're going to change, see this number here, the 0.5? Santiago,
Yeah.
you see that? Let's change that to 0.6 and see what happens to the ellipse. Ooh, now let's change it to 0.7. Now to 0.8. What's happening to the ellipse as that number is getting bigger? Okay, we'll go back to 0.5. Okay, watch what happens, right? Change it to 0.6, 0.7.
It's getting more bigger and bigger and stretching out more.
Yeah, it's stretching out more, isn't it? It is getting taller also, but it's mainly stretching out more, right? Let's do one more to 9, right? Gets pretty long, right? Now something, and in fact, I'm going to change this to 1.0. Watch what happens. Okay, and let me zoom out a bit. Ooh, now it looks like it's stretching forever. I need to get that 0 there. Okay, now that's kind of weird, right? Let's zoom back in. There. Okay, now I'm going to change this to 1.1 and zoom out a bit. Ooh, what just happened? Watch what happens when we go from 1.0 to 1.1. Ooh, now we get two things, right? Santiago, you see it?
Yes, I'm seeing it.
Okay, Aaron, are you seeing this?
Yeah.
Okay, and then or if we change it to 1.2 or 1.3 or 1.4 or 1.5, interesting things are happening, right? So this number, when this number is greater than 1, we get these two parts, right? Two halves, one to the right and one to the left. And we have a name for this thing. It's called a hyperbola. Hyperbola.
Mm-hmm.
So hyperbolas are related to ellipses, right? When that number is less than 1, it's an ellipse, but when that number is greater than 1, it's a hyperbola. How about that?
Oh.
Okay, let me change it back to 0.5. And there's our little ellipse again. Let me zoom back in on that. There it is. Okay, so we zoomed back in again. Okay, now let's reduce this number 0.5. Let's change it to 0.4 and see what happens. 0.4, 0.3, 0.2, 0.1. What's happening to the shape of this ellipse? It's getting closer and closer to what? It looks more and more like a what? Santiago, any idea? Do you know how an ellipse is kind of stretched out, isn't it?
Yeah.
Is this stretched out that much anymore?
No. Is it a circle?
Yeah, it looks more like a circle, doesn't it, Santiago?
Yes.
Okay, and look at that number that I've got in front of the cosine here in the denominator. Right now it's 0.01, right?
Mm-hmm.
Okay, let's change that to 0.0005. Right, it looks even more like a circle. Okay, here's the interesting thing as far as astronomy is concerned. Orbits of planets in the solar system are ellipses, right? But some of the ellipses have this number is a very small number, which means that the ellipse is very close to being a circle. And that's true for the Earth's orbit, right? This number that's in front of the cosine is called the eccentricity. And we use the letter E to represent that, little e, eccentricity. And the eccentricity of the Earth's orbit is a small number, like 0.005. But the eccentricity of other numbers, like Pluto, for example, Pluto has a relatively large eccentricity, like it's close to 0.2. Now, it still kind of looks like a circle, but it is a little bit more stretched out, as you can see on the graphing calculator, right? So, Aaron, are you seeing that? And Santi, you see it?
Yes, I see it.
Okay, right. So I want you guys to be able to understand how that works. Okay, now let me stop sharing my screen for just a moment. Okay, and I'm going to, okay, how do I make this 0? Okay, Aaron, did I answer your question? Let me share it.
Really.
Let me go back to the Desmos screen again. Okay. When you said, how do I make this 0? Do you mean this thing here?
Yeah. I forgot.
Okay, yeah, that's actually a Greek letter. It's called theta. Okay, and here's how I wrote it. I just write Theta, and watch what happens when I write the A.
Yeah.
Ooh, it turns into that thing, right?
Yeah.
Did that make sense? Okay, now that's not a zero. You could think of it as a zero with a horizontal line through it, but that's actually a Greek letter called theta, Theta. That's a good question, Aaron. I'm glad you asked that. Okay, so let me get out of that screen share for a moment, and now I'm going to share my screen with my, let's see. Is that my whiteboard? That's not what I wanted to do. Nope. Maybe it's this one. Nope. Hang on a minute. What I'm trying to do right now is I'm trying to do a screen share. Well, I'm trying to do screen mirroring. There we go. There. Okay. Let me try that again. Okay, can you guys see this board?
Yeah.
Okay, and I'm going to, that's not what I wanted. There, whiteboard. Okay, now here's the equation that we had. We had R equals 7.5 over 1 minus 0.5 cosine theta, right?
Mm-hmm.
Okay, now here's what the equation of the general form of the equation of an ellipse looks like this. It's equal to a, and then parentheses 1 minus e squared over 1 plus or minus e cosine theta. Okay, that's the general equation of an ellipse in polar form. Now, here's what, there's a couple of things here that I want you to see. Just by comparing the two equations, I think you can see that E is equal to 0.5, right? So if you look at the denominator of this fraction and you look at the denominator of this fraction and you compare them, you can see that the two of them, right, the number that's in front of the COS in both cases is 0.5, or rather in the top one is 0.5, and in the bottom one it's E. So that means that E has to be equal to 0.5, right? You guys got that? Santiago? Aaron?
Yes, I got it.
Okay, Aaron,
Yeah.
okay. All right, now here's another thing, right? Let's compare the numerators now. On the top of the top equation, we have 7.5. And on the top of the bottom one, we've got this thing, A times 1 minus e squared. And we're going to say that that's equal to 7.5. Okay, so the top of the second fraction is equal to the top of the first fraction. Okay, and I'm going to lasso these last two parts here and copy them. And we're going to move to, get through all this. We're going to move to this new board here. Let me paste that in there. Okay, so that's what we've got so far. Okay, so I'm going to make a substitution here. I'm going to put 0.5 where we see E in this equation over here. So we're going to get A, excuse me, A times 1 minus, write this in parentheses, 0.5 squared equals 7.5. And what's 5 squared? 5 times 5. Hello?
25.
25.
25. Okay, so 0.5 times 0.5 is going to be 0.25. So we get A times 1 minus 0.25 equals 7.5. Okay, and then what's 100 minus 25?
75.
Santiago?
75.
Yeah, so what's 1 minus 0.25? It's going to be 0.75. So we get A times 0.75 is equal to 7.5. All right so far?
Yeah.
Yeah.
How do you solve that equation? You have to divide both sides of the equation by something. And what would you divide it by?
Would you distribute the A to each side?
No. Okay, this means A times 0.75 equals 7.5, right?
Mm-hmm.
Okay, so let's go to a new screen. If I had something like 5x is equal to 20, that means 5 times x is equal to 20, right?
Yeah.
Okay, how would you solve that equation, Santiago?
I'll divide 5 and 20 by
Divide by
5.
5, right? On both sides of the equation. What happens over here on the left side?
The 20 would turn into a 4, and it'll be x equals 4.
Exactly. Okay, good. All right, so let me clear all this up and remind you what the real equation we want to solve is. The equation that we have is this: 0.75 times A is equal to 7.5.
So then you would divide 0.75 and 7.5 by 0.75?
Yeah, exactly. Okay, so Aaron, right, we would get this, 7.5 over 0.75. And what is that equal to? You guys, ooh, here's a way you can do this. Watch this. This is cool. I'm going to move this decimal point over 2 places, which means I can move this decimal point over 2 places, but I have to add a 0 to do that. So we get A is equal to 750 divided by 75. Ooh,
10?
exactly, 10. Did you like that? Was that cool? Moving the
Yeah.
decimal points around? Yeah, that's kind of awesome. Right, so the answer there, Aaron, was A equals 10. Okay, now that is called the semi-major axis. Okay, and let me go back to the Desmos screen for just a moment. Where'd he go? Okay, so let me change this back to 0.5. Okay. Okay, and do you notice, okay, here's the point 0, 0. Can you guys see my screen?
Yeah.
Yeah.
Okay, do you know, where's this point over here? It's at 10, isn't it? So the semi-major axis is, when it's in polar form, goes from the origin to the other origin. Ooh, that's cool. Right, so that distance A is 10. How about that? We calculated that. Is that cool or what?
Yeah.
Yeah, I think so. Okay, I think we're running out of time. Desmos just told me that we're running out of time. And so I'm going to post this this video to Schoology, okay? So that you guys can watch
Okay.
it again. And this will help you to complete that extra credit assignment about ellipses and in polar form, okay?
Okay.
Okay.
So please do that today. Please complete that assignment today. All right, I would love to see you guys, right, do those assignments and get those grades up. Get those grades up, okay?
Okay.
Get perfect scores,
Okay.
right, Santi?
Yes.
Okay, I'm going to stop recording